In pursuit of transferring technical knowledge and just to gear up for the new engineering entrant, myself Pranav is here to deliver today's presentation, Power Transformer Part 62. As the topic is of the continuation, so for your convenience, the link of the previous one is given under the description box. Let's start with cause of chemical instability within the insulating system. The oil paper insulation condition of oil immersed transformer is of great significance. So, for the safe, stable operation is concerned. Again, I repeat, the oil paper insulation condition of oil immersed transformers is of great significance so far the safe and stable operation is concerned. The primary insulation structure is therefore composed of mineral oil and oil impregnated paper or paperboard insulation. The chemical components of cellulosic insulation system in electrical transformer such as winding paper and pressboard, where the average number of glucose molecules contained in each of the cellulosic cluster is to be determined by its degree of polymerization, which is an indicator for tensile strength of the cellulosic paper element. Again, I repeat, the chemical components of cellulosic insulation system in electrical transformers such as winding paper and pressboard, where the average number of glucose molecules contained in each of the cellulose cluster is to be determined by the degree of polymerization, which is an indicator for tensile strength of the cellulosic paper element. Despite any of the chemical complexity of cellulosic paper element, there may have the two main chemical degradation possibility so far been exploited, rather the actual insulation's reliability of these paper element. Two degradation process are of acid hydrolysis, another is oxidation. The resultant effect of these processes would lead to develop depolymerization of the cellulosic paper element, causing an ultimate loss of their tensile strength. During the pre-oxidation treatment on the cellulosic material, the part of its hydroxymethyl groups on glucose units would have been oxidized to carboxyl acid groups. The carboxyl acid mixing with oil would have to act as the catalytic reagent for the process of hydrolysis, which ultimately leads to instigate the depolymerization of cellulose. All these criteria may have to depend on the type of transformer oil whose specifications would directly impact the performance, reliability, and longevity of the transformer's cellulosic insulation system. See the chart. Transformer oil is obtained by the fractional distillation and subsequent treatment of crude petroleum. Then considerable factors contribute to select transformer oil that decides to ensure optimal transformer performance and longevity. One, must have a high dielectric strength and excellent insulation properties, which ensure effective electrical insulation between the transformer's components. Number two, must have a high thermal conductivity to ensure efficient transfer of heat away from the core and windings. Number three, must possess good oxidation stability and aging characteristics. Oil must have low moisture absorption characteristics and maintain a minimal water content. Number four, must be compatible with the materials used in transformers, such as insulation materials, steels, gaskets, and paint coatings. Number five, must possess an appropriate viscosity to ensure optimal circulation within the transformer facilities, which facilitating efficient heat transfer and cooling. Transformer oils are mostly derived from mineral oils and are of two form, that is two form of petroleum products. One is naphthenic based transformer oil, another is paraffin based transformer oil. Naphthenic based transformer oil, which is a mineral oil, which is rather derived from specific crudes containing very low N paraffin or wax. Their properties of naphthenic oil: one, comparatively more stable at high temperatures. Number two, lower pour point, which indicates higher content of aromatics and lower content of paraffins. Number three, comparatively lower flash point. Number four, difficult to make, totally devoid of sulfur, and with increased temperature may lead to higher rate of corrosivity. Higher the oxidation rate due to presence of aromatics, that is aromatic hydrocarbons, though easier to oxidize, but the oxidation products are soluble within the oil. Comparatively lower viscosity index, typically in the order of below 50. Paraffinic based transformer oil, it is also an mineral oil which is derived from specific crudes containing substantial amount of N-paraffin or wax. Properties of paraffinic oil: one, high wax content causing higher pour point, which indicates higher content of paraffin and lower content of aromatics. Number two, higher flash point. Number three, virtually sulfur free. Number four, oxidation rate is comparatively lower. Number five, oxidation products are insoluble within the oil. Number six, high viscosity index due to presence of wax, typically in the order of above 80. Please note, viscosity index of an element is to be defined as the rate of change in viscosity with changes in temperature. Now, crude oil, an overview. A number of different petroleum products that are to be produced from crude oil. Mineral insulating oil, as used for transformer oil, is normally obtained by fractional distillation and subsequent treatment of crude petroleum oil. The crude oil is composed of a complex mixture of hydrocarbon compounds such as paraffins, naphthens, and aromatics, plus small amount of organic and inorganic compounds, including atoms of sulfur, oxygen, and nitrogen, as well as a trace of metallic compounds of iron, vanadium, nickel, chromium, and sodium salts. Though the concentration of non-hydrocarbon compounds in crude oil significantly very small, but their influence would have been quite significant during the operational cycle of catalytic petroleum processing system. Basic composition of crude oil. Hydrocarbon compounds, that is saturated aliphatic hydrocarbons, one. Saturated aliphatic hydrocarbons is of two types. One is paraffins, that is alkanes, and cycloparaffins, that is naphthens or cycloalkanes. Number two, unsaturated aliphatic hydrocarbons, that is olefins, which is called alkenes. Number three, special class of unsaturated hydrocarbons, which is aromatic hydrocarbons. Special class of unsaturated hydrocarbons, which is aromatic hydrocarbons. Organic non-hydrocarbons constituents small amounts of organic compounds of sulfur, oxygen, and nitrogen. Metallic compounds like traces of iron, vanadium, nickel, chromium, and sodium salts. Points to be noted that most of the paraffin hydrocarbons in naturally obtained crude oils are in straight chains, that is normal paraffins, N-paraffins, while branched chain, that is isoparaffins, are often produced in refinery processes. Another point, alkanes are the saturated hydrocarbons. Alkanes are the unsaturated hydrocarbons. These 2 points to be noted. It is rather concluded that the unrefined petroleum or crude oil, which is principally composed of hydrocarbons, would usually be obtained from beneath the Earth's surface. So, crude oil is a natural fluid with having a complex mixture of aliphatic and aromatic hydrocarbons along with polar compounds, resins, and asphaltenes. Asphaltenes and resins both are the nonpolar and non-volatile components of crude oil. Asphaltenes are being insoluble in alkanes but readily soluble in aromatics, that is benzene and toluene. In case of resins, they are soluble in normal alkanes and aromatic solvents, but not in liquid propane. Asphaltenes would have the physical property of very high molecular weight. As the asphaltenes constituents are being the heavier and most polar compounds in crude oil, so these compounds would rather be in non-distillable state and remain in the remain in the residual fuels after the completion of total process of distillable fractions. Whereas resins that have the physical property of lower molecular weight, higher hydrogen to carbon ratio, and fewer heteroatoms, those atoms other than carbon and hydrogen. However, the basic difference between the two are lying at the proportions of carbon and hydrogen aromatic rings as comprised in their respective constituent compositions. Asphaltenes, there may have the composition with more than 50% of the total carbon as aromatic carbon. Points to be noted. In asphaltenes, there may have the composition with more than 50% of the total carbon as aromatic carbon. Whereas the proportion of the total carbon occurring as aromatic carbon is significantly lower in case of resin constituents. That's the basic difference in between asphaltenes and resin. Resins are being strongly attracted by asphaltenes and rather be impossible to separate resins from asphaltenes. Asphaltenes are mainly composed of carbon, hydrogen, oxygen, sulfur, and nitrogen, with having a trace of vanadium, nickel, iron, and aluminium. Asphaltene would have different functional groups within its molecular structure. Resins fraction of crude oil is often containing heteroatoms, heteroatoms such as nitrogen, oxygen, or sulfur, and that makes to a heavier fraction than aromatics and saturated hydrocarbons. Part of the crude oil had to contain the higher molecular weight resins and asphaltenes would have to make that part of the oil much more viscous, that is, to have an obvious increase of viscosity along with the portion of the oil itself. Say the diagram. That is constituents of crude oil, organic compounds, heteroatom, organic compounds, that is sulfur, nitrogen, oxygen, constituent of hydrocarbons, carbon and hydrogen are the largest group of organic compounds. Organic compounds like nickel, vanadium, iron. Inorganic compounds, that is sodium, calcium, chlorine, metals and salts. In figure 182, chemical constitution of crude oil is categorically mentioned, where the hydrocarbons would be the largest group of organic compounds found in crude oil. There might have been several thousands of different hydrocarbon compounds in crude oil, of which are usually divided into 4 groups. Again, I repeat, there might have been several thousands of different hydrocarbon compounds in crude oil, which are usually divided into 4 groups. One is paraffins, number 2, naphthens, number 3, olefins, number 4, aromatics, out of which first 3 are sometimes denoted as aliphatic compounds. First 2 is saturated hydrocarbons, and olefins is the unsaturated hydrocarbons but aliphatic in compounds. In normal circumstances, crude oil is a complex mixture of hydrocarbon molecules which include methane, ethane, propane, and butane, and that will exist as dissolved gases, out of which methane is the lightest hydrocarbon, and it has been exhibited that the methane content in crude oil is normally be rather relatively low compared to other hydrocarbons. Classification of crude oils is mostly categorized on the basis of chemical composition as corresponds to the actual proportion of hydrocarbon constituents. Paraffinic crude oils that must be rich in high molecular weight paraffin hydrocarbons or alkane hydrocarbons. Paraffins are the homologous series of saturated hydrocarbons with having the generalized formula CnH2n plus 2, where C is a carbon atom, H is a hydrogen atom, and N is an integer. Paraffins are referred to as a group of alkanes, which would have been divided into two groups. One is normal paraffin, that is N paraffins, or normal alkanes or N alkanes, which are open, straight chain, saturated hydrocarbons. Isoparaffins, number two, which are branched chain saturated hydrocarbons. Usually, it has been exhibited that most of the cases, paraffins with the normal straight chain varieties are more likely to present in crude oil rather than branched chain structures. The physical and chemical properties of paraffins can be distinctly categorized as corresponds to the general formula CnH2n plus 2. For values of n greater than 5, n is the integer. For values of n is greater than 5, then paraffins or paraffin hydrocarbons would be of gaseous state. Sorry, for values of n is less than 5, paraffin or paraffin hydrocarbons would be of gaseous state at normal temperatures and pressures, which include the compounds methane, ethane, propane, and butane. Again, I repeat, for values of n is less than 5, then paraffins or paraffin hydrocarbons would be of gaseous state at normal temperatures and pressures, which include the compounds methane, ethane, propane, and butane. For values n is equal to 5 to n is equal to 15, the paraffins would be of liquid state at normal temperatures and pressures. For values n is greater than 15, the natural grading of paraffins would be of the state from viscous liquids to solid waxes rather. A comprehensive chart is framed with this categorization of paraffins. See the chart. N is less than 5, that is methane, ethane, propane, butane, which are rather in gaseous state at normal temperature and pressures, and N is equal to 5 to N is equal to 15, up to 15, 5 to 15, that is pentane, hexane, heptane, octane, nonane, decane, undecane, dodecan, tridecan, tetradecan, pentadecan. These paraffins are in liquid state at normal temperature and pressures. When N is greater than 15, then grade of paraffins would have been from viscous liquids to uh, solid rather substances. Then N is greater than 15, grade of paraffins would have been from viscous liquids to solid viscous or solid wax rather. As a matter of fact, there would have been a direct relationship between the number of carbon atoms in the chemical structure of the different category of paraffin hydrocarbons and their perspective melting point temperature ranges. Higher be the carbon atoms in paraffin hydrocarbon chains, the higher would be the melting point. Important. Higher be the carbon atoms in paraffin hydrocarbon chains, the higher would be their melting point. According to the table, it is obvious to note that each member of these paraffins would have to differ from the next higher and the next lower member by the direct interference of a CH2 group, that is methylene group. Subjective chemical and physical properties that would have also to change gradually as carbon atoms are added to the chain. Paraffin hydrocarbons in crude oil would have to organize in such a way that the carbon atoms are used to connect by a single bond and the other bonds are saturated with hydrogen atoms. Crude oils are therefore to be classified on the basis of chemical composition as corresponds to the properties of hydrocarbon constituents. It is to understand with having the feature as stated in paraffinic crude oils, where they are basically rich in straight chain and branched paraffin hydrocarbons, whereas in naphthenic crude oils that would constitute mainly with the composition of naphthenic and aromatic hydrocarbons. However, most of the crude oils would have a smaller percentage of aromatic hydrocarbons, that is unsaturated hydrocarbons, and that contain at least one aromatic ring, of which benzene C6H6 is the simplest form. Aromatic hydrocarbons are the most important series of stable and unsaturated cyclic compounds, which are thus to be composed of one or more benzene rings. Let's stop here, further to be continued at later stage. Thank you. Thank you for listening the video. Kindly do like, share and subscribe. Your subscriptions would encourage to post more videos. Also share your comments and or feedbacks inside the dedicated comment section. If you have any suggestions or specific topic you want, then let me know in the comment section, please. Thank you. Thank you for patient hearing.